there, Rich. Okay, so the next page we're just going to talk about briefly what type of method to use when. So when is graphically a very appropriate method to use? When both equations are y equals or a variable equals. Both equations are y equals. That's a great time to use graphical. When is it not appropriate to use graphical? So they're both not y equals. And if the question says solve algebraically. If it says solve algebraically, you are not allowed to use graphical. All right, when is it appropriate to use substitution? There's two, it has to be a system, but all of these have to be systems. But we need when one equation is x equals or y equals. Or we can make it x equals or y equals. When one equation is x equals or y equals. And also when they say solve algebraically, then you can use this method. So one of them is x equals or, it doesn't have to be both, but if it easily can be made x equals or y equals, then it's really easy to sub it into the other. When is it not appropriate to use substitution? When it says solve graphically or solve by elimination. Solve by elimination. Basically, it says you can't use it. They're telling you you have to use this method. Elimination is our adding and subtracting method. When is it appropriate to use elimination? What do the equations usually look like? They line up. What form is that? Does anyone remember the name of that form? No? Standard. So both equations are standard form. Are standard form. So standard form is they have to line up. Ax plus by equals our constant. Right? Ax plus by equals our constant. And also if it says or solve algebraically, you can use this method. So if it says solve algebraically, you can use either substitution or elimination, but not graphical. And when is it not appropriate to use? If it says solve graphically or solve by substitution. Okay, so the following problems we're going to choose a method each time. So we're either going to choose graphical, elimination, or substitution. We've already done one question with graphical, so we're going to try some algebraic approaches for this next question. A playoff game drew 36,500 fans. Depending on seat location, the ticket prices were either $35 or $20. Total revenue from the ticket sales was $940,000. How many $35 tickets and how many $20 tickets were sold? So is this a problem where you can use a chart? Why? Is the answer yes? Because there's numbers. There's a total number. There's two totals. A total number of fans and a total number of money. So you can make a chart if you like. What do you want to? What are the two unknowns here? Look at the question. Look at how many 35 tickets? This is the question. How many $20 tickets? So those are our two variables. What variable would you like to use? X and Y. Sure. First come, first serve. X and Y were chosen. So x would be, no, we can just say just 35. Not the cost, we know the cost. How many means the number of $35 tickets. Okay, how many $20 tickets? So our variable for y is the number of $20 tickets. I guess we should say sold. Sold. All right, so these ones always have five steps. First step, remember from previous, is define our variables. Second step, write the equation. So this was step 1. Okay, step 2, let's write our equations. Now, if you'd like to use a chart, you can here. Or remember, all the money goes together, and all the variables and total number go together. Let's make a chart maybe. A really small chart. Might not fit, but let's try. So our two situations are the $35 and the $20. So what would be the cost of a $35 ticket? Sounds like a really dumb question. $35. And the cost of a $20 ticket? $20. How many $35 tickets do we have? This is where our variables go. So x, this would be the number. So this times this equals total value. So a number of $20 tickets, y. So this would be 35x and 20y. How many, this is our total. So total number, 36,500. And total value, total money brought in, $940,000. And there's our two equations. Remember our two equations? X plus y equals 36,500, and then we have, do that to the whole screen. That's 35x plus 20y equals 940,000. Do you have to make a chart? No. If you can make those without a chart, good for you. Chart can help though. Okay, so let's write our two equations. X plus y equals 36,500, and then 35x plus 20y, 940,000. Okay, the question, we're not going to solve graphically because we already did that one. So elimination or substitution? Let's do elimination because I'm going to tell you now substitution is going to be really good for the next question. So let's do this one with elimination. Okay, so step, there's our second equation. If we're going to choose elimination, what is elimination? What do we do in elimination? Make the x or y coefficients the same. And so we can add or subtract. So who do we want to make the same, the x's or the y's? Sure, y it is. It's a smaller number. So how are we going to make the y's the same? Multiply equation 1 by 20. Now here's a little tip for some of you. I'm going to move down here, step 3. Some of you, I've noticed, don't always get the answer right when you use subtraction. Right? So instead, let's make them opposite signs. So instead of making this a positive 20y, the signs are the same, I'm going to multiply it by a negative 20. Or you could just switch the signs yourself after. If you're fine with subtraction and you don't make a mistake, then go for it. But if you make mistakes with subtraction, then this is what you should probably do. Okay, so negative 20x times minus 20y equals, I can do this, 73,000 negative? No? I might be wrong. 73. Yeah. Oh, there's one more zero. Yes, yes, yes. 730,000. That's the other zero. So that's our equation 1. And then our equation 2 was 35x and plus 20y equals 940,000. So I made them opposite signs. Why? Well, if I have a negative 20y and a plus 20y, what can we do? By addition or subtraction? Addition. They're going to cancel out by addition. Negative 20 plus 35 plus 15x. Some of you, if you were subtracting, you'll get a negative 15x. Negative 730,000 plus 940,000 is 210. If you were subtracting, you get negative 210. And then divide both sides by 15. Oh, see, this is what happens when you turn up the heat. And x equals 14,000. 14,000. Okay. This is some of you are so cute because you get to this point, you celebrate, and you get so excited celebrating, you forget to do what? Solve for y. So now we need to find y. How am I gonna get y? They both be negative, and then you divide by negative, negative, so you still get positive in the end. So how do we get y? Yeah, Jaden, thank you. Put x, let's put it into 1 because it's easier. It doesn't matter which one though. So but, I wrote but, I meant put. X equals 14,000 into 1. So 14,000 plus y has to equal 36,500. Subtract 14,000 and we get, what did you get for y? Someone solve it already? 21,500, right? Oh, yeah. Silly me. 22,500. And, okay, step 4. Check with who? Second one, because we subbed into 1 here. So we're going to do our check with 2. 35 times our x of 14,000 plus 20 times 22,500 has to equal $940,000. You just type it in here. You type it in. Does it give you 940,000? Yep. Yay. Now there's 5 steps. We're in step 4. Write a sentence. Step 5, therefore. On a word problem, yeah. But they're not all going to be word problems. Therefore, they sold 14,000 tickets at what price? $35 and 22,500 tickets at $20. Now, just so you know, I know this is a lot of work, and so if you make one silly mistake, you're still gonna get partial credit. You're not gonna get like a 0 to get it wrong, right? You show your work, you write on those steps, you get credit for them. Well, you could do that. Yeah. If there's a test, I might be a little bit more, you know, like if I was you, I would just be very careful. Either it'll tell you by elimination or by substitution, or the test will say choose. I promise you that one question is going to be by, I'll say specifically by elimination or by substitution, and then the other two questions, it'll be your choice. So you could choose, yeah, all of them would work. Just choosing your method you'd like. All right, next question. For Battle of the Bands, one adult ticket costs $6 and one student ticket costs $4. 3 times as many student tickets as adult tickets were sold. Total revenue was $756. I think what we'll do for this question is we're going to just make the formulas, do the first 2 steps, and then we'll actually solve the next question. And so we'll just get this one started, but we'll solve the next problem. Okay? So what I'd like you to do is A, come up with the variables, come up with the equation. Okay? So come up with what are the unknowns, what are the 2 things I'm looking for, and choose a variable, doesn't matter the variables you choose, and then come up with the equations. But most of you choose A and S, or X and Y is fine too. And you can't just say A is adults, you had to say the number of adult tickets sold. This is where English comes in, right? Writing sentences. Y or S would be the number of student tickets sold. So your first equation, remember all the money goes together. So it says one adult ticket costs $6 for an adult ticket. One student ticket costs $4, and they raised $756. So what's our first equation? 6A, or X, depending on what you use, plus 4S equals 56. There's your first equation. Okay, the next one, it says there are 3 times as many, remember each sentence is usually an equation, 3 times as many student tickets as adult tickets were sold. So the easiest way to make your equation here when we have something like that is to figure out, okay, who do we have more of? Students or adults? Students. It says we have 3 times as many students as we do adults, and we want to make them equal. So in order to make them equal, I'm going to go students equals, so the larger number equals. What are we going to do to the adults to make them equivalent? Times it by 3. 3 times the number of adults equals the number of students. So let's solve this one because this one's really nicely set up for what method? No! Well, you could do graphically. Substitution! It's not always often that one's set up nicely for. So let's use substitution. So how do we use substitution? We sub, because we already have S equals, equation 2 into, sub 2 into equation 1. Remember doing this? Yeah? We kind of like forgot about it because we got so used to elimination. So which variable in equation 1 are we going to replace? S, because we have S equals. And when we replace, what do we have to remember? Bracket. So 6A plus 4 bracket. What is S equal to? 3A equals 756. 4 times 3A, 12A. So we have 6A plus 12A equals 756. Then we combine like terms. 6 and 12 equal 18. 18. And then we, 6 plus 12 is 18. Divide both sides by 18. A is 42. What's going on? What's wrong? So we use substitution, not elimination. So because we had S equals, we know S is equal to this. And so we sub that into equation 2. All right, now you know A. How do we get S? Sub A equals 42. Which one do you want to put it in? Into 2, sure. 2 is easier. So S is equal to 3 times A. What's our A? 42, which gives us 126. And then last, who do you check with? Well, actually second last. We subbed into 2, so we're going to check with 1. 6 times 42 plus 4 times 126 has to equal 756. 6 times 42, 240 plus 12, 256. 2, yes. Plus 4 times 126, 504, which equals 756. That was easy, hey? That one was really easy. You might have a test question just like this. Therefore, 42 adults and 126 students went to Battle of the Bands. These questions take so long that by the end of it, you're like, what are we solving for again? What is the context? That's why we write what our variables mean. Okay, so the last question, all we're going to do is set up the equation. And then if you'd like to solve, you're welcome to, and I can write the solution on the board. But I want to give you some time for homework. So we're just going to kind of set it up. Alrighty? You can use a chart for this one. It's transfer your chart skills. What I would like you to do is try and set up the equation. Set up the equation. So when $10,000 is invested in a GIC, which was at a rate of 8%, and a mutual fund, which was at 12%. At the end of 1 year, Lisa earns a total of $1,120 in interest from both investments. How much did she invest at each rate? Okay, let's read this one more time. She won 10 grand. Woohoo! She invested. Okay? Part of it she puts at 8%, part of it she splits it. But not evenly. She just takes a chunk of the money and puts it in an 8% and the other chunk into 12%. So she takes that 10,000 and breaks it apart. Okay? Now at the end of the year, she earns $1,120 in interest total from both of them combined. Okay? The question says how much did she invest at each rate? So that tells us our variables. X we'll say is how much she invested at 8%. How much invested in the GIC or at 8%? Nope, because it could be like $4,200 and in one and then 58 in the other. Yeah, and it's split up, but it's not split up evenly. It's not 5,000 and 5,000. It could be 3,000, 7,000, right? And Y would be how much invested at 12%. Okay, now let me show you. A chart works totally good with this because we have two different totals, right? We have the total amount of money invested and we have the total amount of interest earned. And the formula is very similar to that of when we have value money problems. Let me show you. You don't have to use a chart. You might have figured it out on your own. One of the equations should be obvious. Now we have our X, or 8%, and our GIC and our mutual fund. Mutual fund. So those are the two situations, and then totals go down here. And so our rate times the amount of money we invest gives us the interest earned in that investment. Right? If I invest $100 at 5%, I'm going to earn $5. 5% times 100 is $5. So the GIC, what was the percentage that I invested at? 8%. And what do we have to do with percentages? Change them to decimals. So we're going to write it as decimal 0.8, 0.08. And then our 12% would be 0.12. Remember, we divided by 100. Per cent, century, 100, per 100. So 8 out of 100, 12 out of 100. The amount of money we invested in the GIC, how much did we invest? What always goes here? Our variable. So amount of money in 8% was, we called, oops, go back to there you go, X and Y. And then again, the amount of money earned in the GIC would then be 0.08X, 0.12Y. Okay, total money goes here. How much total money did we invest? 10,000. And then interest earned total was 1,120. And there's your two equations. Right? All the interest, you could have done this without a chart, all the interest goes together. So $1,120 in interest, 8%, 12%. Those are my interest rates. Goes with your interest. Those all go together. Okay, so there's your two equations. 0.08x plus 0.12y equals 1,120. And then x plus y equals 10,000. All right, so at this point, you could either solve it, right? Do you guys want to solve this one right now on your own? Or do you want to start your homework? Start your homework? Okay, for those of you who want to solve it, I'm going to write down the solution on the board. And for those of you who would like to get started on homework, you can. A little note about your homework. Can everyone please open up? There's 3 parts to your homework, so 9 questions. Can everyone open up to page 449? I just need to give you a little instruction about numbers 14 and 17. Now, you've seen these problems yesterday in your homework. And yesterday, all you had to do was say if there's one solution, no solution, or infinite. I chose these 2 questions because they're great word problems, and I know that there is one solution. And so for these 2 problems, what I'd like you to do is actually solve. So yesterday you saw 14. So 14 yesterday in your homework, all you had to do is just say if there's one solution, no solution, or infinite. You didn't actually have to solve the problems. If you did, then you already got it done. Okay? So for these ones, I actually want you to solve them. Find the answer that makes that equation true. Okay, that makes sense? All right, so for those of you, you're welcome to get started on homework. I will write the solution on the board so you can check if you got the same one, if you worked ahead, or if you want to try that problem. Yeah. Okay, so I'm going to use substitution. Okay, so sub 2 into 1. What's wrong, Jordan? Okay.